So hi everyone, so in this video, me, Noatirah, and my friend Fatin Shira are going to present about our project, More Parking System project. So this is the enlightenment on how our system works. So there is a sensor area. So the sensor will detect a car coming if there is a car coming, and the user need to enter the password, and if the user enter the password right, the car can pass through the gate and enter the mall. Okay. So this is the table of contents. There is an introduction, process, result, and discussion, and conclusion. So for introduction, how do we get the password that the user must enter to enter the mall? So you must register your name either manual or online. Okay. So why do we need this system in the first place? So first reason is we don't need to hire a worker, and the second reason is to avoid queue up for making payment. So in order to making payment for this parking system, you have to pay it through debit card or credit card.
Next, we go into the summary of method. In designing the simulation, we use always statement, always at asterisk statement, if else statement, case statement, and assign statement. First, the time scale is 1 ns over 1 ps. It is a guide for setting the clock at waveform. Then the module for car parking system represent the car parking system that have 6 input, which clock, reset, sensor entrance, and sensor exit, and the password 1 and password 2. It also has 4 output, which are green LED, red LED, hex 1 and hex 2. The parameter consists of 5 states that following the step-by-step in the system for the car coming until the car enter the parking. At first, we go to the next state. We use always statement. In the always statement, the clock and reset are in the sensitivity list. It is because the appropriate event on either signal will cause one of the 2 if branches to execute. The positive edge clock and negative edge reset are as the timing control of the always statement, because it must be executed only on the rising edge of the clock and the falling edge of the reset. So if the system reset, the current state will be idle, which at the first state. If not reset, the current state will change to the next state. Next, we go to the counter wait state. We also use always statement. The counter wait start at 0. Then, if the sensor detect a car coming, the counter wait will +1, and current state at the wait password state. If not, the counter wait will remain the same. Next, at the change state, we use always at asterisk. This always at asterisk statement is used when the input and elements that change its value as soon as one or more of its input change. Next, we use case statement for current state. The case statement checks if the given expression matches one of the other expression in the list and branches accordingly. Next, we go to the idle state. At the idle state, if the sensor entrance is equals to 1, next state will become wait password. Else, if no car detected, the state will stay in idle state. In the wait password, if the counter wait is +1, next state will become wait password. Then, when the entered password is correct, the next state will be in right password state. Else, if the entered password is incorrect, the next state will be in wrong password state. In the wrong password state, if the password correct, the next state will be in right password state, and if still wrong, the state will not go to the next state. In the right password state, if the password is correct, the next state will go to the stop state if have next car at behind. The stop state is for the new car coming. Then, if the car enter the car parking, the sensor exit will detect and system will become 1. The next state will be an idle state, else next state will be right password. And lastly, in the stop state, if the password correct, next state will be a right password, and continue next step with following the previous explanation. And if the password is incorrect, the state will remain the state. Then we end case. Next, we use case statement in current state. After that, we go to the output part. The hex 1 and hex 2 is the output will we get in the waveform result. For example, the output is 111111 and 111111. We can know that it was an idle state where the gate not glow any color of the LED. At the wait password, green will be 1 bit 0 and red will be 1 bit 1. So the hex 1 and hex 2 are stated. At wrong password, green and red will remain the same, and hex 1 and hex 2 are also stated. At the right password, green will glow and red will be 1 bit 0, and the hex 1 and hex 2 are also stated. At the stop state, the green will become 1 bit 0 and red will glow. The hex 1 and hex 2 are stated. So after that, we end case. Lastly, assign red LED and green LED. In Verilog, assign statement is the signal of type wire or a similar wire like data type requires the continuous assignment of a value. Then end module. Next, we go to the discussion of result. First, we go to the right password flow. First, we set the right password, which is 0110. Reset 1, sensor exit and sensor entrance and clock. This is full waveform from the Verilog code for the car parking system. As we can see, first state is in the idle state. The green light and red light is at off condition. We can see that both lights are equal to 0. Hex 1 and hex 2 are both 111111, which we can see the code are verified in this condition. The sensor entrance is equal to 1, sensor exit is equal to 0. The idle state moves to the next state, which is wait password. We can see the hex 1 00001110 and hex 2 101011. Next, the continuation waveform. As we can see, user is insert the right password, which is 0110. Then the output hex 1 000010 and hex 2 10000000, which are the same as the right password condition. Then the red light becomes 0 and the green light will go to allow the car enter the parking. When the sensor exit is equals to 1 and sensor entrance is equals to 1, so the red light will toggle to the green light. The red light will glow for the new car entrance, the hex 1 001010 and the hex 2 000110, which is at the stop state, while the car exit is continued same waveform, which is at the right password. When sensor entrance is equal to 0 and sensor exit is equals to 1, then no new car coming. The output from the output form will be hex 1 and hex 2 is both 1111111. Next, we go to the wrong password flow. At the first waveform is not detecting the state because it was not positive edge clock. Then after the clock at positive edge clock, the next state is at the idle state. Then the waveform change to the wait password state. To ask the user, enter the password. If the user enter the wrong password, which is we can see the user enter the 0010, we can see the next state become the wrong password state. Then after the user enter the right password, next state will change to the right password state. The green light will blink to allow the car enter into the car parking. At the same time, the system show the stop state for the next car and the red light will blink.
Okay, so we are in the last part, which is conclusion. So as we all know, it is the Verilog HDL is most commonly used in design and verification of digital circuits at the register transfer level of abstraction. So it is also used for designing. It does help us to make rough design of our mall system parking project. It is also easy to debug if there is an error, easy to recheck. The parameter and the case statement is also easy to understand, so it is easier to beginner to learn. Okay. And I am sure that Verilog HDL will use many more in the future, because nowadays also Verilog HDL is really helpful in workplace and to design a hardware. So that's all from us. Thank you.